Hello, my name is Siti Nazura. Today, I will explain about the concept of metrological traceability and its role in analytical laboratory. So what is measurement traceability? According to International Vocabulary of Metrology, VIM, metrological traceability or measurement traceability is a property of a measurement result whereby the result can be related to a reference through a documented unbroken chain of calibration and each contributing to the measurement uncertainty. VIM provides some supplementary notes that should be taken into consideration, which a reference can be a definition of a measurement unit through its practical realization, or a measurement procedure including the measurement unit for a non-ordinal quantity or a measurement standard. Metrological traceability requires an established calibration hierarchy. Specification of the reference must include the time at which this reference was used in establishing the calibration hierarchy, along with any other relevant metrological information about the reference, such as when the first calibration in the calibration hierarchy was performed. Measurements with more than one input quantity in the measurement model, each of the input quantity values should itself be metrologically traceable, and the calibration hierarchy involved may form a branch structure or a network. This is measurement traceability pyramid, which commonly use graphical representation to demonstrate measurement traceability and the calibration hierarchy from the realization of the SI unit down to the measurement performed in the industrial environment. Traceability is the ability to trace, for example, the origin of a product. The word can be derived from the Latin tractus, which means drown, or the verb trahere, to draw. Traceability can refer to documentation, for example, a sampling procedure, a laboratory analysis, or method. But as in ISO IEC 17025, we deals with traceability of measurement results. That is, measurement results have to be traceable to the metrological reference used. So ideally, the references should be the values of national and international standard expressed in SI units. The traceability is realized through change of calibrations, the traceability change. For temperature and many other physical quantities, such as mass and time, the traceability is easily established. In addition, in chemistry, the working standard are substances with defined purity, solution of pure substances, and metric reference materials. Example for application of measurement principles is to determine mass concentration of ethanol in breath, where mass concentration of ethanol in breath is measured by infrared spectroscopy. Evidential breath analyzers are verified and calibrated using aqueous ethanol solution or dry gas mixtures consisting of ethanol and air. In former times, the solution have been made by gravimetric dilution of absolute ethanol with water. The hygroscopic nature of ethanol causes an unknown deviation of the solution concentrations from the supposed one. It is difficult to obtain a reasonable estimate of the measurement bias that this effect causes, and so to correct the deviation and estimate the measurement uncertainty. It is therefore necessary to measure the ethanol mass fraction in the calibration solution. This is done by several methods, including titration with dichromate and by gas chromatography. Metrological traceability chain of measurement result obtained with an evidential breath analyzer calibrated via gas chromatography. Measurement uncertainties are given as relative standard measurement uncertainties. To ensure international metrological comparability of measurement results and to become aware of possible measurement biases, international comparisons have been organized by the CCQM. For ethanol water mixtures, a first comparison for forensic matrices was made in 2002, a study that included the Australian NMI. It showed that even at the highest level of measurement capabilities, measurement biases can arise. As an example, it is shown how the metrological traceability chain of a breath alcohol measurement bag to a national standard has been realized in Australia, where a metrological traceable quantity value for an ethanol measurement standard is obtained by the measurement of the ethanol mass fraction of a solution by isotope dilution mass spectrometer (IDMS). This calibrator is provided to calibration authorities who prepare working calibrated ethanol solutions that are supplied to the police to calibrate field breath analyzer measurement system. So method validation demonstrates that the method which in set of conditions used in a particular laboratory at a certain time was fit for purpose and all significant effects were identified. Calibration of critical equipment completes the metrological traceability chains. Measurement uncertainty is estimated from the method validation and the traceability. Quality control, whether it is internal and external, ensures that the measurement results, including uncertainty, are of the same quality as at the time of validation. As a conclusion, the traceability of a measurement result refers to metrological traceability as defined by VIM. It relates the result to SI units or other agreed standard or references. Traceability is essential for comparability of result and is a requirement of ISO IEC 17025. Traceability is easily achieved following good laboratory practice.